Alright, so now here we look at how to determine a function to be even or odd function. And this is one of the discussion topics in 2.2. Alright, so now as examples, as we have had a few examples in class, but here let's look at some more examples so that you can get more comfortable. The basic steps is always going to be the same with what we've done in class. So in example 1, we want to determine whether f of x is even or odd or neither. Some function can be neither odd nor even. So the function f of x here is f of x equals x to the fourth minus x squared. Okay, so always to check whether a function is being even or odd or neither, you always need to start out by replacing. If you notice this function right here, the input is the x, so now you're gonna have to substitute. You're gonna have to replace the input by a minus x. So here, instead of the usual x, I'm gonna substitute minus x into the function, and then I'm gonna have to go ahead and evaluate my function at minus x. So here, keep in mind that we're evaluating a negative x, a minus x. So I have to do minus x in quantity raised to the fourth power, because once again the minus x takes over the whole place of the x in my function. So and then minus x all square, because keep in mind the square here is to square the entire input, and my input is replaced by the minus x, so I need to square the entire quantity minus x. And now here, continuing with the evaluation process here, minus x to the fourth power equals to positive x to the fourth minus x squared. The minus sign here is the same, but minus x all square is going to be just simply x squared. So now, after plugging in a minus x into a function, after substituting a minus x into the function, and finish evaluating, I ended out with a new function which is exactly or identically equals to the starting function f of x. And so now at this point, remember, when you're substituting in a minus x into the function and it turns out to be exactly equals to the starting out function, the original function, then that means here we have an even function. So you can say that the function x to the fourth minus x squared is an even function. Okay, so here in a different example, let's look for even or odd or neither. Okay. And the function that we have here, f of x equals how about x to the fourth, how about x to the sixth, actually x to the sixth plus x squared plus 1. And then once again, let's try if this function here is even or odd or neither. So once again, the starting point is always with the functions. Now you're going to replace the input x by a minus x. Okay, so I'm substituting a negative x into the inputs of my functions. And so now, taking the new inputs here and evaluating that, I'm going to have minus x quantity to the sixth power plus minus x quantity to the square power plus 1. And then continuing with the evaluation process, what I have is minus x to the sixth is going to be a positive x to the sixth plus minus x all square is going to be positive x squared plus 1. And here at this point, my final expression right here, after evaluation, the function at a negative x, it turns out to be exactly or precisely equals to the original function, because x squared plus x to the sixth plus x squared plus 1 equals to the function f of x itself. And so here I can just safely say that it equals to f of x. So you can see that f of minus x precisely equals to f of x, the starting function. That implies here, once again, we have an even function. Okay. So that's the answer. In a different example, how about example number 3 now? We want to, once again, we want to see whether this function here is even or odd, or neither. Okay. And so now my function this time is f of x equals x to the 7 minus x cubed. And so now once again, the way to start out with this problem, you always need to replace the input argument of the function by a minus x. So I'm taking f, I'm evaluating f at minus x, and that would equals to minus x all quantity to the 7 minus x all cubed. And now evaluating all these expressions here, that's going to give me minus x to the 7 minus a minus x cubed, and those two minus here is going to make it a plus x cubed. And so now this final function right here, what I'm seeing here is if you compare the final function, the final expression with the original functions, it seems like every single term is just the exact switch in the sign. So if you're looking at x to the 7 term, the original sign was a positive sign, and here it's a minus sign. So you switch over. The original x cubed term was a minus sign, and in this case right here we have a switch to a positive. So that means if you observe and you see that for every term there's precisely a switch in a sign, so that means the functions evaluated at minus x is indeed equals to the function f of x itself with a minus sign in front. It equals to the negative. So the negative here is just indicating the fact that every single term is switched in sign. Okay, so that's indicating that my function taking minus x for the input equals to the opposites of the original functions, or in symbol it's a minus in front and the function f of x, and that implies this is a satisfaction to the condition for being an odd function. So my function in this case is odd function. So we are now legal to say that the function is an odd function. So let's look again at a different example. Here we're looking at example number 4. Is it odd or even or neither? Okay, and here I'm looking at f of x equals x to the 5th. How about minus x to the 5th plus x? Okay, so once again the starting point is always going to be, you're going to replace the input arguments by a minus x, and so that is going to go into the input to replace for the x. And so here I have the minus and then minus x all to the 5th power plus and then minus x. Keep in mind the reason I'm using parentheses all over is because I'm indicating an entire substitution of the x. I entirely replace the x, just the x, by a minus x, and the 5th power belongs to the input, but the minus sign in front does not belong to the x. So here's the minus sign keep coming along. So now minus x all to the 5th power is minus x to the 5th. With a minus here, it's going to become positive x to the 5th minus x altogether. And now here at my final expression right here, if you compare term by term with the original functions, you're looking at the x to the 5th. The original function has a minus term for x to the 5th, and here it's switched over to a positive sign. In the x term, the original function started out with plus, and here in the final line right here it says minus x. So it seems like once again similar setup that we had earlier. Every single term here has an exact switch in signs. So that means when I'm evaluating my function f at minus x, it's gonna turn out to be equals to the function f of x multiplied with the minus in front. It's equals to the opposite. It equals to the opposite of the function f of x, or multiplying the function f of x by a negative sign in front. And that means this function here is an odd function again. So now in my example number 5, we want to do, is this going to be even or odd or neither? So the function I'm having here is about x to the 4th power minus x. Okay, and here what I'm having here, once again, starting out point, replace the input arguments by a minus x, and that turns out to be minus x all in quantity to the 4th power minus x, and all this here is going to become positive x to the 4th plus x. And so here's my final expressions after I evaluate the function at minus x. But look at what's happening here. If you compare the two functions term by term, the final function here, the final expression here, in terms of the x to the 4th, it stays the same. The first term remains the same, but the last term, the x term, has a switch in the sign. So here we have a combination between, terms remaining the same sign, and then some term gets switched in sign. So here's the case where, so that means the function taking the minus x input is not precisely equals to the original function, but neither it's equals to the opposite. Neither it's equal to the opposite of the function as well. So that means here we have a neither. It's neither odd or even. Okay. So in the last example, is this gonna be odd or even or neither? And the function I'm having here is f of x equals x to the 3rd power plus 1. Simple function. And here, once again, starting out point is to replace the input arguments by a minus x. And here what I'm having here is minus x all cubed plus 1. And here that turns out to be minus x cubed plus 1. And here's, once again, that's my final expression. And if I'm comparing term by term, the x cubed term does get a switch in sign, but the constant term 1 does not change in sign at all. So that means the function at x equals, the function at negative x is not equals to the original function itself. Neither it's equals to the opposite of the original function. So now, in that case, once again, here my function is a neither odd nor even.